Welcome to my YouTube channel. In this video lecture, we are going to continue solving next questions from CRP5 chapter in Keith Williams' General Navigation book. So let's begin. Question number 11. True heading is given, task is given, winds are given to you. What is ground speed? So let's substitute the values. True heading is 090, task 200, winds 220 at 30. This gives you a ground speed of 220.48 knots. So approximately 220 knots. Select that option which is closest to this value. Question number 12. Aeroplane is flying at a true airspeed of 180 knots on 090 track. Winds are given. How far can the aeroplane fly out from its base and return in 1 hour? Okay. So over here, we will have to use point of no return formula. Over here, now we know distance to PNR, or distance to point of no return equals to endurance into outbound ground speed into homebound ground speed divided by outbound plus homebound. Time to PNR will be distance to PNR divided by outbound ground speed. Okay. Now what is distance to PNR? It is nothing but E into O into H divided by O plus H and this outbound ground speed, right? So this this outbound speed gets cancelled. We are left with a residue that time to PNR equals to endurance into homebound speed divided by outbound plus homebound. Okay. Now we will substitute the values in time to PNR formula. Okay. Endurance is what? 1 hour. We are flying this plane for 1 hour. We will put outbound. We'll put outbound speeds and homebound speeds. Get time to PNR. Once we get time to PNR, we will be able to find distance to PNR. Okay. So, and that distance will be our final answer. That is that long your airplane can go and come back to its departure point. So see here, your true airspeed is 180, track is 090, winds is 045 at 50. Okay. So you should make a table like we always do for CP PNR questions. Now for PNR, you have to make two tables, one table, two rows. The first will be for your, okay, first will be for your track. So the first column, track column, task column, wind velocity and ground speed. So you first write your outbound ground speed, homebound ground speed. So this is your point A, departure point. This is your destination B. Between them lies your PNR, point of no return. So your plane is to fly from A to this PNR and then back to A and then back to A. Okay. So going outbound from A to PNR, this will be our outbound ground speed. Let's substitute the values or let's fill this table. Track is 090, task is 180, winds are 045 at 50. So track 90, task 180 and winds at 45 degree 50 knots. 50. So the correct answer is outbound ground speed will be 141 knots. 141. Now coming back from PNR to point A, This track will be your 270 reciprocal track. TAS remains the same, winds remain the same, ground speed will become 212 knots. 212. So putting these values in your time to PNR formula, you get time to PNR equals to endurance into homebound speed divided by outbound plus homebound. So 1 multiplied by 212 divided by 212 plus 141. So 212 divided by 353. 353. So this gives you a value of 212 divided by 353 equals to 36 minutes. Equals to 36 minutes. Therefore, distance to PNR will be equal to time to PNR multiplied by outbound ground speed. Time to PNR is 36 minutes. Outbound ground speed is 141. So into 141 is 84.6, approximately 85 nautical miles. So our final answer is how far this airplane can fly out from its base and return in 1 hour. That is 85 nautical miles. It can go up to 85 nautical miles and come back in 1 hour. Okay, so this is how you do it. Simple. Next, question number 13. Following information is displayed on INS: ground speed, heading, drift, task, temperature, what are winds. Now with the help of true heading and drift angle, you can get true track. We all know that whenever there is a starboard drift, the heading of your aircraft is going to be less than track. A starboard drift of 5 degrees, track of, okay, heading of 090. So what will be your track? Track will be equal to 090 plus 5, 095, 095 degree. Okay. Now let's substitute these values. Ground speed 520, as 480, heading 090 and track 095. So wind speed will be 59 knots, wind direction 320. So 320, 59. This will be your final answer. Question 14. The reported surface wind from the control tower is so and so, runway is so and so. What is the crosswind component? This is your northern datum. Runway 300 will be oriented in such a manner. Runway 30, runway 12. Winds are coming from 240 at 35. 240 at 35 means somewhat from this direction. Your takeoff direction is runway 30. Okay. Now we have to find out crosswind component. Now crosswind component equals to wind speed into sine theta. So wind speed is 35 knots. Sine theta. What is theta? Theta is equal to your wind direction minus your runway direction. So that is 240 minus 300 minus 60. So sine of minus 60. So sine of minus 60 is the value that you get in your CX calculator. Multiply that by 35, you get an answer of minus 30 knots. Over here, minus sign represents that the winds are coming from your left hand side, and 30 knot is the wind, is the crosswind component. Crosswind component. Okay, so you're getting a crosswind of 30 knots from left. as represented in this diagram. Question 15, task outside temperature and the flight level. Calculate Mach number. Easy. Mach number is task divided by local speed of sound, which is 485 divided by, now local speed of sound is equal to 39.17 root of temperature in Kelvin. What is the outside temperature here? It is ISA plus 10. So ISA temperature. Now ISA temperature at flight level 410 is minus 56.5 degrees Celsius. In ISA atmospheric conditions, beginning from flight level 360, that is 36,000 feet to 65,000 feet, the temperature remains constant at minus 56.5. Therefore, flight level 410, you expect to get a ISA temperature of minus 56.5. So outside air temperature will be minus 56.5 plus 10 minus 46.5 Celsius. Convert this into Kelvin. You get an answer of 226.5 Kelvin. Consider 226 only. 39.17, 226. So root of that is 15. So 39.17 into 15 is 588.8, 589 knots. So 485 divided by 589 is equal to zero point 0.8. 0.8. Okay. 0.823 actually. So select that option which is closest to this value. Question 16. 265 US gallon equals to what? Specific gravity equals to mass in kilogram upon volume in liters. Okay. Specific gravity is 0.8. We have to find out mass. Volume is 265 US gallon. Convert this into liter, corresponding liter. So 265 US gallon, press convert unit until you get liter. So the value in liters, which is 1003. So 1003. So mass will be equal to zero point 0.8 into 1003, 802.4 kilogram. Okay. Question 17. 730 feet per minute equals to how much? In knots. Now 1 knot equals to 101.3 feet per minute. So 730 feet per minute equals to how much? How many knots? So x will be equal to 730 divided by 101.3. 730 divided by 101.3 equals to 7.2 knots. Now convert this into meter per second. 1 knot equals to 0.515 meter per second. So 7.2 knots will be equal to how many meter per second? It will be equal to 7.2 into 0.515, 3.7 meter per second. Okay. Next. How long will it take to fly 5 nautical miles distance at a speed of 269 knots? So time will be equal to distance by speed. Distance is 5 nautical miles. Speed is 269 knots. Okay. So 5 divided by 269. How long will it fly? Is 1 minute 7 seconds. How long will it? Yeah. So 5 divided by 269, 1 minute 7 seconds. Question number 19. An aircraft travels 2.4 statute miles in 47 seconds. Okay. So let me check the question. 19. Aircraft travels 2.4 statute miles in 47 seconds. What is the ground speed? So we'll convert this 2.4 statute miles into nautical miles. 1 nautical mile equals to 1.15 statute miles. So 2.4 will be how many? 0.4 divided by 1.15, that is 2.08 nautical miles. So approximately 2 nautical miles. So now we have to find speed, which is distance divided by time. Okay. So now we have time in 47 seconds. Let's first use time 47 minutes. So distance is 2 nautical mile divided by 47 minutes into 60 in the numerator. So 2 into 60 divided by 47 is 2.5 knots. Okay, this is the speed when you are flying for 47 minutes. Now to convert, now when you are flying for 47 seconds, the speed will be how much? So for when time is equal to 47 seconds, speed will be 2.5 knots multiplied by 60, which is 150 knots. So just 1 minute equals to 60 seconds. So multiply that by 60. So it will be equal to 150 knots. The closest option here is 160 knots. So select that option. Question number 20. What is the ISA temperature at flight level 330? ISA temperature equals to 15 degrees Celsius minus uh, 2 into thousands of feet altitude. Altitude in thousands of feet. So 15 degrees Celsius minus 2 into 33,000. So 33. 15 minus 66. 15 minus 66 is minus 51. Minus 51 degree Celsius. With this, we come to the end of this lecture. I hope you have understood this simple 10 questions. If not, let me know in the comment box. I'll resolve that doubts. And I thank you all for your time. Subscribe to this channel if you haven't yet, and share this video with all your friends who are preparing for the exam. I'll see you in my next video lecture in which I'll solve the next questions. See you.